Hi, let's now close Module 6, Participation of Renewables in Electricity Market, with its third block, Offering Renewable Energy Under Uncertainty. There, we will revisit some of the market participation strategies we discussed in the first block, and for that we'll be using some of our learnings from the second block regarding the news vendor problem. But first of all, let's remember our setup where the students of the course 31761 gathered to start an energy trading company. This company has an asset with nominal capacity 350 megawatt, and it's kind of a wind farm. The energy generation is sold through the Nord Pool Western Denmark area DK1. Finally, you have balanced responsibility, which means that you will have to be financially responsible through the balancing market for any deviation between the clearing schedule and what is actually generated. Then, from early 2016, we are gathering data and knowledge so as to design market participation strategies for the Nord Pool. In the first block, we have looked at three different types of market participation strategy. The first one, let's trust the forecast, directly using the forecast for offering in the market. Then we've been tweaking the forecast, and then we've been even bold by offering nominal capacity whatever happens throughout the day. The point of block 1 was to show, first of all, that forecast errors will eventually lead to some losses compared to the perfect information case, and we've defined a performance ratio to actually look at the performance of these strategies. And also, if one doesn't have access to a perfect forecast, then one may try to be aware of the uncertainty of this forecast and also aware of the market penalization and its asymmetry. In practice, our setup was that we looked on the 27th of March 2016 at 11 in the morning, so just before gate closure, at what we should offer for the following day for the 24 market time units between midnight and midnight. In the first block, the basic quantity we used was this forecast with values for each and every hour of the day, which were expressed in power originally, but allowed to deduce energy generation. The basic question behind that was, how much will we actually offer? From trust the forecast, to tweaking it, to being bold, we've analyzed how the performance ratio would evolve. But now that we think about it, it is a news vendor problem, don't you think? Let's focus on the market time unit I, and let's say it's the hour between 1 and 2 in the afternoon. It could be any other hour. We have a set of price, a day-ahead price, lambda IS, a down-regulation price, lambda I with an arrow pointing downwards, and an up-regulation price, lambda I with an arrow pointing upwards. So why is this a news vendor problem? We have to make a decision. It's a one-shot decision to be made before gate closure. We have to figure out how much energy generation we want to offer for each and every market time unit. The actual renewable energy generation is uncertain. Even though we have a forecast, we're not really 100% sure of what's going to happen. Then, as we said in previous block, the marginal profit and losses are known. If you look at this set of prices, we can define a pi plus I as the difference between day-ahead price and down-regulation price for any generated megawatt hour above the day-ahead schedule. Indeed, for each and every of these units, we have an opportunity loss. We could have been paid lambda S if offering this amount in the market, in the day-ahead market in the first place, but since we've not, we are going to get paid only this amount through the balancing stage. So the opportunity loss is the difference between these two prices. On the other side, for upregulation, we have been paid lambda S through the day-ahead market clearing, and since we are not delivering, so for any of these lacking megawatt hours with respect to the day-ahead schedule, we will have to pay this price lambda I arrow pointing upwards, which is going to be penalizing since this price is higher than lambda S. These two quantities, pi I plus and pi I minus, are greater or equal to 0 since always these differences are either zero or actually penalizing. Our aim here is to definitely maximize expected profit, which is what we define in the news vendor problem. So how do we obtain the optimal offer? Remember that for our Roskilde ticket pusher problem, we showed that the optimal offer is an optimal quantile from the cumulative distribution function of our uncertain quantity. Here the uncertain quantity is renewable power generation, and so we need a cumulative distribution function for it. And then we have the nominal level of the optimal quantile, which we can deduce from the ratio between pi plus and pi plus pi minus. So that sounds very easy and straightforward, but actually we don't know f, we don't know pi plus, and we don't know pi minus. We definitely will need some forecast there so that we can plug, instead of having the real f and the real nominal level, we will use a forecast for f, a forecasted cumulative distribution function, and a forecasted nominal level for the optimal quantile. For renewable energy generation first, we have been given a forecast from our forecast vendor. This forecast vendor gave us a single trajectory in the future, but actually most of the forecast vendors today can also give some probabilistic information. So this is how it would look like. This is the same plot as we had before, with the forecast originally given in red. Here we also have in black the measurements that were collected a posteriori. And these different bands with varying shades will tell us about different probabilities of power generation being within certain ranges. We will discuss that, the definition of such probabilistic forecast, in a further module. The point is that if you were to look at a certain market time unit and reinterpret the bounds of this probabilistic forecast, you can actually define the cumulative distribution function for renewable energy generation. Here, for the example of this market time unit, you can see this curve that gives the probability here in the y-axis of producing less or equal to a certain power or energy value between 0 and the nominal capacity of the asset. So we have access to a forecast for the cumulative distribution function. On the other side, we need some information, being expert assessment or forecast, for the potential market penalties that we discussed before, pi minus and pi plus. There maybe the same forecast provider could help you, or you could have a market expert in-house that can also give you some best guess estimate. Eventually, we can represent that in the form of a loss function that will tell what could be the loss for any positive deviation from schedule and any negative deviation from schedule. Here the slope for the two parts of our loss function will be the penalties that we have previously defined. So on one side we'll have a slope of pi plus, on the other side we'll have a slope of pi minus. On this example one that we'll use for this trading day, this trading sample day, we have this slope of 7 here on one side that represent a penalization of 7 corner, which is the spread between the day-ahead price and the down-regulation price. And on the other side, we have a slope of 2, which represent the spread between the up-regulation price and the day-ahead price. We assume here that we've made the same forecast, we have the same expert guess for the 24 market time units that we have. So for each and every of these market time unit, we have the nominal level of our optimal quantile being alpha I equals 7/9, and that's 0.78. This for each and every market time unit. If we go back to our probabilistic forecast, we can then extract this optimal quantile for each and every market time unit. And this is what we have added on this plot here. This is the same information as before, but here in blue, this is the optimal quantile that we have extracted based on the optimal nominal level we deduced of 0.78. So for each and every hour, we obtain here in blue what we will offer in the market following a news vendor-like strategy. If we were to look at the results from the trading strategy, we have a day-ahead revenue of 122,771 euros and 40 cents, which is quite high. And then we have revenues from the balancing market, which are actually negative. It's a payment of minus 36,030 euro and 97 cents. All in all, by adding these two, we get a revenue which is equal to the revenue we would have with perfect information of 80,627 euro and 50 cents. The performance ratio is therefore 100% or 1. And why is that? It's because basically with this assessment we add with the penalization and the asymmetry, we do as for the let's be bold strategy, we place ourselves on the right side. We tend to over-promise through the market, and by being scheduled for more than what we're actually going to produce, we place ourselves in a situation of up-regulation. But we saw with the market prices that in this day, being in an up-regulation situation was not penalizing. So we end up in this case, by being on the right side, you will actually not be penalized and have a performance ratio of 100%. Eventually, this was only results for a single day. And does that mean that we can repeat that every day afterwards? It's not really sure. Indeed, the outcome of this news vendor strategy can highly fluctuate from one day to the next, even from 1 hour to the next. It is an optimal strategy in expectation. And I explained that in expectation means as an average over all potential outcomes of our uncertain variable, here being renewable power generation. Also here in expectation would mean that if we were to repeat this game under the same conditions strictly over and over again, if we were to do that infinitely, then we are sure this was the best strategy to apply. However, here, there are a lot of assumptions. We are not going to play the same game over and over again, forever. There will be a limited amount of time, and the conditions of the game will change every hour, every day, etc. Also, we base ourselves on forecasts for the knowledge of the penalization in the markets. In the original definition of the news vendor problem, we said that these values should be known. Here they cannot be known as we cannot know the prices in the market in advance. All in all, that means that applying a news vendor strategy seems to be a good idea to account for uncertainty and asymmetries in the market, but you may be tempted to bring another layer of analytics and smartness if you want these strategies to actually pay off. To illustrate that point, let me show you some results for trading strategy for a portfolio in Denmark, a power portfolio over a period of 9 months, so with a lot of program time units here, more than 7,000. And these different curves show the net cumulated revenues that you would get with different strategy compared to the strategy which is to directly use the point forecast, so let's trust the forecast. In blue here, we have the results from the news vendor strategy. And you see that it is a bumpy ride. There are some days with very steep increase in these cumulated revenues, but there are also some days with very large losses. Basically, over this one program time unit, you're losing what you gained over the last 2 or 3 months in terms of extra revenues by applying this more advanced strategy. And then you're trying to catch up again. So you can see this is a bumpy ride. The other curves here are resulting from applying another layer of analytics, trying to dampen the potential negative effects of the news vendor strategy. In practice, the reason why we may have these big losses is that we can make bold mistakes in the renewable power generation, but mainly we make mistakes in the asymmetry in market penalties. So to correct for that, the idea of the various strategies that are implemented here are to have some kind of band around the point forecast and then to dampen the use of the news vendor strategy if this news vendor strategy seems to deviate too much from the let's trust the forecast strategy. So if you want, the idea is to blend the original let's trust the forecast with the aggressive, you could say, news vendor strategy, and all in all, it seems to result in more steady and higher revenues in the market. Thank you for listening. Now I would like to invite you to use the self-assessment quiz to check your understanding.